All right. Ooh, we can zoom in a little bit. Okay, so the first thing we're going to do is we're going to code in the weekly. I think we coded in, we're going to code in the daily. I think we coded in weekly yesterday. So weekly, yesterday's weekly, does the same thing monthly did. The idea of these interest rates is they're going to give you what's called an APR, an annual percentage rate. That is the rate that they give you over the whole year. But depending on how many times it's compounded, that governs how large that rate is. So for example, we already talked that annually, so the compounding is annual, you get the full 2%, or whatever percent it is. If the compounding is monthly, you get 2% divided by 12 months. And I think the logic, if there is logic, it's banking. But if there is logic, I think the idea is, since they compound it 12 times, if you add that to itself 12 times, you get 2%. I don't know if there is logic. That's the only way that's the only way to get 2% out of that, is to add it to itself 12 times, which means you'd have 12 different compounds. Using that logic, it also applies to weekly and daily. So for weekly, you take the 2% and divide it by how many weeks in a year there are, which is 52. Ish. 52, it's 52 point whatever, like 52. Ish. Right, it's 52.14, but I think they use 52 for the rate, I think. And then daily, you'd have to take the 2% and divide it by 365. Now again, I don't know if the banks use that. If they use 365.24, I don't know. Let's just use these numbers because I think it makes the most sense to us logically. None of these numbers are perfect. There aren't exactly 12 equal months in a year. That means the compounds are happening after different numbers of days. So, but this is kind of how you have to deal with those interest rates within each of your Gesundheit, within each of your formulas. Okay. That makes sense, friends? So it's like continuing the monthly stuff into the weekly and the daily. So you would literally just do the same thing in your spreadsheets. There we go. Do the exact same thing in your spreadsheets. So for weekly, I'm going to show you what I did. You can tell me if you like it or not. I used our exponential trick. Who likes the exponent thing that we just learned on the warm-up? Oh boy, a couple people. Okay, I'm gonna do this one exponentially, the other one linearly. So we'll do it both ways. So I did it with Shit, I said I was going to be better today. You're kind. Okay. So what I did was I took $100, multiplied it by the rate, which is 1 plus, and then you can see the rate right there. I put 0.02 divided by 52. That's for a weekly. And then I raised it to how many powers it is, which is this over here. If you use a different formula, that is totally fine. I'll actually do it probably the way y'all did it, maybe. You did 100, and then you did 1 plus 0.02 divided by 52 times the previous. And you'll notice they're exactly the same thing. If I make them dollars, they're exactly the same. There's no difference between the two formulas. They are doing the same thing. One is simply reevaluating one's called an explicit formula and one is called a recursive formula. Not that you have to know either of those terms mathematically. A recursive, you might remember actually, we did these before on the first day of class when we were doing the card decks. Because I said, how do you figure out how many ways you can deal out decks of cards? And we started with 1 card, and then 2 cards, and then 3 cards. And somebody in here, I have no idea who it was, discovered that if you knew how many ways you could deal out 3 cards, you could take that number and multiply it by 4 to get 4 cards. And then if you knew that number, you could take that number, multiply it by 5 to get 5 cards. And it was really cool. And that's called recursive, which is like this way. But the problem with that one on the first day of class was we ran into a brick wall because we would have never been done. So then we figured out what's called the explicit, which is over here. But either way it works. They're both fine. They both work. Okay, so there's your weekly. Daily, same thing. Daily, same thing, except you start with $100, and then you multiply the $100 times 1 plus 0.02 divided by 365. Drag that puppy dog down. Hopefully these numbers look like the numbers you're getting. Fair? Take a look, not fair. I'll make them bigger so you can see them. Some of you have a hard time seeing them. Go. This is weekly. Excuse me, I just lied. This is daily. The first few dailies. Here are the first few weeklies. First few weeklies. Monthlies and annuals already did yesterday, so. Okay, my awesome friends. Next question is a fun one, I think. I say fun, you get worried. Which method of compounding resulted in the greatest amount of savings over 10 years? Daily. Make sure. So some of you, it looked with the rounded version of monthly like monthly was doing better. But if you actually use the exact rate, daily beats weekly, weekly beats monthly, and monthly beats annually. So it looks like the more compounds there are over a given time period, the better that's going to be. I'll never ask you to prove that mathematically, which is a pain in the ass. Okay. It makes sense exponentially, but to prove it is a little bit more tricky. But I don't care about proving that. There's something more important to do. Because here's the deal. Actually, I want you to read the next two paragraphs. Read the next two paragraphs before I talk over them. Give yourself a couple minutes, read those next two paragraphs.